Welcome back. In this video, we are going to continue our discussion of production. We are actually going to focus on short run production. Okay, and because we have only two inputs in this topic when we're discussing it in this class anyway, we have just labor and capital. So in the short run, we're saying that there's one fixed input and one varied input, or one variable. Now this fixed input is why we know we're in the short run. Okay, now we assume typically that capital is fixed in the short run, because you can typically hire and fire people a lot easier than you can capital. Okay, so we assume that capital K is fixed, and that means that labor L is variable, implying that in the short run, the only way to increase output rather, is to increase labor, because we cannot affect capital. Okay, so let's talk about some other things here too. Actually, I'm going to do this on a separate page. So we have our short run production function. Bear with me here. All right, so our short run production function is Q is equal to F of L and a fixed value of K. Sometimes this is called K hat, sometimes K bar. Either way, we're just saying that K is fixed at a certain number. So we have, this is workers or labor, this is fixed capital, and here we have output. Now note that the total product of labor, which is what this function is, shows us the total product. I think I can switch colors here. This shows us the total product that a given amount of labor can produce, given, holding the quantity of the other inputs, which in our case is just capital, fixed. So basically we can see how many units that we can produce as L changes. Remember, we want this to be efficient. Next, we have the marginal product of labor. Now, you should be used to this term marginal at this point. It's just saying additional, right? We've seen it with the consumer. So marginal product of labor really is just saying the additional unit of production, additional Q, that a new unit of L can produce, right? So let's write that out. So this is the change in total output resulting from using an extra unit of labor, holding as usual other factors constant. For us, that's capital constant. So with the marginal product of labor, just when you hear marginal, think additional, like the next added, right? The additional product of labor, the marginal product of labor. It's saying that, this is called MPL. I'm gonna switch colors again here. So MPL here is saying how does Q change when L changes. I'm using partial here because we could have more than just L in the function, right? The Q is a function of L and K. We could have other things. So if you want to expand it, then we're looking for that partial change in Q caused by just the one thing, L, right? So how does L change? Sorry, how does Q change when L changes? By 1 unit. Okay. So I can expand this here. Since we have just L and K in ours, and K is fixed, this is really a full derivative, but to make it applicable everywhere, we'll just keep it at partial. So we have df L K bar dl, right? How does a change in L affect what is being produced, given that we know how labor enters our production and how capital enters our production? All right, so next we have average product of labor. We're taking the time to learn these terms because they show up when we're trying to determine the optimal quantity of something, optimal number of inputs. Like these things show up. So if we know what they are, if we know what they're asking us to say or to find, then doing the math should be a little bit easier. All right, so average product of labor here, right? Average. So if everyone is counted equally, basically, how many would we produce? How many would each person produce? So this is the ratio of output to the number of workers used to produce that output. So APL here is total quantity produced divided by labor. That is, if for instance everybody together produced 100 units and there were 10 people, then on average each person produced 10 units per person. But it's possible that one person, Ben actually made 20, Billy made 2, right? We could have, I don't know, Bossa made 20, and then we have Batman maybe made 4, and so on. But all of them together, if we count them as equal people, we would say that on average, the average person made 10 units. Okay. Just quick understanding there. I'm gonna erase this part, the B names. Okay, so now that we've talked about what these things are conceptually, let's actually apply them to an example. So if, for instance, we have an example. There's a local computer assembly firm's production function. You should be used to this term by now. When you hear production function, you should be thinking Q is equal to some function of L and K. Right. So their production function is, okay, so Q is equal to 0.1 LK plus 3L2 L squared K minus 0.1 L cubed K. So we know how this firm combines your labor and capital, right, to efficiently produce some output here. All right, so with this information, if the question is asking us, sorry, the eraser is being a little stubborn. If the question is asking us what is the short run production function, now the moment we see short run, we know something is fixed, right? One of them is fixed if K bar is equal to 10, right? So capital is fixed. And then if it also asks us to find, right, what is MPL and APL. We're familiar with those terms. So let's go ahead and get started. What is the short run production if capital is fixed at 10? Well, that means we just need to plug in K is equal to 10 into production function. Right, so we have Q is equal to 0.1 L times 10 plus 3 10 to the power of 2 K. Is that true? No, right? Because we have fixed capital, not fixed labor. Okay. Minus 0.1. If you got that, good job. L cubed times 10. So we can expand this. 10 times 0.1, just move the decimal place ahead 1. So we have 1L plus 30L squared minus, again, move that to that decimal 1 because of the 10. Okay, 1L cubed. In case you're wondering, 0.1 is just 1 over 10. So 0.1 times 10 would be equal to 1 over 10 times 10, and those can cross out. Okay. So now that we have that, right, not bad at all. We're saying if capital is fixed at the level of 10, so maybe they have 10 desktops or something where they assemble all their production, then we're going to be able to tell how the number of computers assembled will vary as labor varies. So Q is equal to L plus 30L squared minus L to the third. Now the next question is, what is MPL and what is APL? We know that MPL here is asking us how does quantity change when labor changes. Right, we're going from this function here. So we have the derivative of, notice I'm using full here. That's because in here they're full derivative. There's only one variable L. So how does this change? As L changes. So we have the derivative of L, so L to the power of 1, we bring the 1 down, and then we have 1 minus 1, which is 1 times L to the power of 0, and anything to the power of 0 is just 1, so we have 1 times 1, which is 1. Alright, so we have 1 there, plus, bring the 2 down, subtract 1, 60L to the power of 1, minus, bring the 3 down, subtract 1, 3L squared. Okay? Alright. Hopefully that makes sense to you. Next we have APL. APL, unlike, MPL, which is saying like if we hire the next person, they will be able to produce, shouldn't have done that. If we hire the next person, they'll be able to produce this much quantity. 2. Unlike MPL, APL is saying is if we put everybody's production together, what will we have as each person producing? Right, so APL is equal to total production over labor, or is equal to Q over L. Remember that this is our Q. We just found that first. So we have L plus 30 L squared minus L to the third. I'm copying it from here. All of that divided by L. This is different from taking a derivative of this, but just doing a pure division. So this is similar to saying L over L plus 30 L squared over L minus L cubed over L. Right, we can distribute the L evenly. So this would be equal to 1 plus, cross out, plus 30L minus L squared. This is our average product of labor. Hopefully all of this that we just discussed is clear. We did go through some math, but so some calculus showed up here. But again, we did go through that in the first part with consumption. If it isn't clear, please ask. Send me an email, sign up for my office hours. Let's go over it together. Good job watching this. See you in the next video.